Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello and welcome. My name is Janet Douglas, a biomedical engineer with Oxygen Alliance. Today, I will take you through the third and last episode of our video series on troubleshooting low oxygen purity on various models of oxygen concentrators. The World Health Organization recommends an oxygen purity of greater than 82%, and anything below this value is considered low. In our previous episodes, we covered low or unstable voltages, leakages, faulty control boards, dirty air filters, and faulty control valves. You can find the links of these videos in our description below. Assuming all faults mentioned in our previous episodes have been corrected and the oxygen concentrator is still producing low oxygen purity, you can proceed to check other components of the unit. One of such components is the sieve bed check valves. In some concentrator models, for example, this DeVille BIS 1025, a manifold is used to combine connections from the sieve beds to the product tank. It contains built-in check valves instead of individual ones, and these valves are responsible for directing the flow of oxygen from the sieve beds to the oxygen tank and not allowing it back into the sieve bed. In some cases, a check valve may develop a leak, allowing generated oxygen to escape. A leaking check valve also allows backflow of air. As a result, oxygen from the pressurizing sieve bed and from the product tank flows back into the depressurizing sieve bed. This backflow prevents the pressurizing sieve bed from reaching a required pressure for effective nitrogen adsorption, and the concentrator's performance drops. In other oxygen concentrator model, for example, this DeVille BIS 525, incorrect installation of a check valve could also cause low oxygen purity. And this is because a reversed check valve can cause the backflow of oxygen. To demonstrate the effect of the check valve placement on oxygen purity, I will reverse the direction of this check valve. But before I do that, I would like to verify the oxygen purity of this concentrator when the check valve is positioned in the right direction. I will turn on the machine to measure the oxygen concentration of this oxygen concentrator. So as you can see, the measured oxygen purity is 95.6%. So let's see what would happen to this concentration if we reverse the direction of the check valve. Now, I will reverse the direction of this check valve. It is important to use a flathead screwdriver So earlier the direction was this way, and now I'm going to reverse it. After doing this, we are going to test the oxygen purity. So I'll do the same procedure, turning on the concentrator and measuring it using an oxygen analyzer. As you may recall, initially we found an oxygen purity of 95.6, but now after reversing the direction of the check valve, we are getting a value below 50%. And this just shows us that if we reverse the direction of the check valve, it really affects the oxygen purity, and it is always important that we verify or check the direction of the valve if at all want to replace it. I'll now replace the correct orientation of this check valve. Another cause of low oxygen purity is degraded zeolite. Oxygen concentrators have two sieve beds, as you can see, and these are filled with a material called zeolite. Zeolite separates nitrogen from compressed air, thereby concentrating oxygen. Over time, zeolite degrades, and this can be accelerated by factors such as exposure to moisture. This reduces its efficiency in absorbing nitrogen. As a result, more nitrogen remains in the air passing through the sieve beds, leading to decreased oxygen purity. The simplest way to confirm zeolite degradation is to install the suspected sieve beds in a properly working oxygen concentrator. If the concentrator then produces low oxygen purity, it indicates that the zeolite in those sieve beds is degraded. The most common solution for degraded zeolite is to replace the sieve beds with new ones or the ones that are working. However, it is also possible to refill the same sieve beds with fresh zeolite. The link of a video on sieve bed refilling is in the description below. The last cause of low oxygen purity is a worn-out compressor kit. The compressor is responsible for generating sufficient air pressure required for effective PSA cycles. For this oxygen concentrator, it is expected that the compressor should be able to generate pressure to around 40 psi, which is the operating pressure for the concentrator. Failure for the compressor to generate this pressure can cause low oxygen purity. In most cases, compressor failure is a result of worn-out compressor kit, which includes cylinder sleeves, cylinder caps, gaskets, O-rings, and flapper or reed valves. Components such as O-rings, gaskets, cylinder sleeves, and caps maintain airtight seals and ensure efficient air compression. Over time, these may wear out and begin to leak. Air leakages reduces the compressor's ability to produce the necessary pressure required for nitrogen absorption. As a result, nitrogen is not fully absorbed, and this leads to low oxygen purity. Regular inspections of these parts is necessary to ensure that the compressor is able to perform efficiently. In addition, flapper or reed valves controls air intake or exhaust within the compressor chamber. They play a crucial role in maintaining the pressure required for PSA cycles by ensuring that air flows into the chamber during the intake stroke and out of the sieve bed during the compression stroke. Over time, these valves may leak or lose effectiveness due to wear and tear. It is important to clean the valve plates, and faulty fiber valves should be replaced. A link of a video on how to service the compressor is in the description below. With that, we have covered 3 more potential causes of log impurity. And this is all that we had for you today. Please don't forget to hit the subscription button and the notification bell so that you do not miss on our upcoming videos. Bye!